それではこれよりイスラエル製品であるモルフィセックのメーカーからの動画メッセージをご紹介いたします。モルフィセックとは2つ前の担当者負担軽減の工夫をご紹介いたしましたセッションで登場したエンドポイントソリューションでございます。全く新しい技術を用いた防御法によって攻撃を問わずあらゆる脅威からエンドポイントを保護することができます。メーカーならではの製品説明と作り手の思いが込められた動画となっております。それではモルフィセック社 ER 氏からのメッセージをお送りいたします。
Hello, my name is Eyal Rosen, and I'm from Morphisec. I'm a sales director in charge of the Asian and European markets, and I will speak to you today about the company and about its very unique endpoint security solution. Morphisec is an endpoint security and workload security company. And to put things in the right perspective and in the right context, when we speak about the endpoint security world, we speak about three main concepts: prevention and detection and remediation, which usually go together. Prevention is the proactive approach of keeping attacks out of the network altogether, preventing them, where detection and remediation are the more reactive approach, which take an assumption of post-breach, meaning at some point of time, the network will be breached. Now, what will be the necessary detection and remediation steps to take to minimize the damage? From a strategic point of view, I am sure you will all agree that prevention is where the focus should be, because if we are able to keep attacks out of the network altogether in a proactive approach, we turn basically detection and remediation into something redundant. And this was indeed the case a few years back, where there are a lot fewer attacks, and the attacks were a lot less complex. They were a lot simpler. And the companies at the time, the security companies at the time, and this is maybe the most important aspect, they had the prior knowledge about those few attacks and therefore were capable to keep them out of the network and to do sort of prevention. But over time, especially over the past 4 years or so, prevention has been eroded and attacks have become a lot more complex, and there are a lot more attacks altogether, and therefore vendors found it more and more difficult to do prevention, and from lack of choice they had to fall back on detection and remediation. And this is what we see today with all the endpoint security companies. They are all detection based, and most important, they all rely, at least to some extent, on prior knowledge. Even the high-end solutions, which use very advanced technologies on their own, like behavioral analysis or sandbox or machine learning, they are all prior knowledge based, at least to some extent, which means they're all very capable to what they know about. But if a new attack is presented or a new attack hits the networks, which these systems do not know about, they are completely useless. And we see this every day with zero-day attacks, which is a term which basically means attacks which use new technology that the existing solutions do not know how to confront. What Morphisec is capable of doing, Morphisec brings back the focus to prevention. Morphisec segmentizes an endpoint to a disk and to memory, basically. Morphisec focuses on the memory. And the reason Morphisec focuses on the memory is that memory-based attacks are becoming more and more popular, and they're becoming more and more popular because the memory is very challenging to protect. And those very few companies which are capable of covering the memory do it with the price of huge impact on the performance of the endpoint. Morphisec does not have this kind of impact, and I will elaborate on that in the further slides. And Morphisec takes pride on the fact that it is capable of preventing virtually all evasive attacks which are trying to use the memory of the endpoint as a gateway into the network. The way Morphisec does that is by implementing a technology which is called moving target defense. Morphisec did not invent the phrase moving target defense, but it is implementing it. And to understand how moving target defense differs from the way that all the other solutions work today, we will focus again on the memory of the endpoint, Windows-based applications, and their loading. Why are we focusing on their loading? Because when Windows-based applications are being loaded, that's where their vulnerability, in case they have a vulnerability, is exposed and can be exploitable. It can be attacked. Now, the process of loading inside the Windows environment has been ongoing in the exact same way for many, many years, for nearly 10 years. And we call that a static approach. Static because it hasn't changed, and therefore rather difficult to defend, because if something is repeating itself in the exact same way, it turns easier to attack. And the way that existing companies confront that problem is that they're building rings and rings of protection around the memory structure, as the memory structure itself repeats itself in the loading process in a static way. Therefore, the data inside is rather easy to attack. The way, again, to confront this, as you can see in the slide, is building rings and rings of protection around the memory structure with the sensitive data it contains. Now, these rings of protection can be an antivirus, they can be a next generation antivirus, as you see here in the slide, and then they can be an EDR solution, an endpoint detection and response solution, and so forth. The problem with these kind of solutions is that eventually they'll be bypassed by the attackers, because the attackers have all the time in the world to examine these solutions, to study them, and eventually find a way to bypass them. And this is what we're seeing on a daily basis. Now, this problem was identified already back in 2013 by the United States Department of Homeland Security, that came and said that the static nature of computer networks and systems make them easy to attack and therefore hard to defend because they're static. And they were reaching out to companies that they believed can change this. And they're the ones who came out with the phrase moving target defense. They were looking for companies who would implement something different. Morphisec takes pride that the DHS has contacted Morphisec, and Morphisec is the only non-US company which was being contacted. And the way Morphisec has implemented moving target defense is, instead of building rings and rings around this static nature or static behavior of the memory structure, Morphisec manages to take this memory structure and move it inside the runtime memory, moving it from one place to another, turning it into a moving target. Naturally, once something is a moving target, it's much more difficult to attack it, and therefore the rules of the game are reversed. Instead of the defenders being on the lower hand, continuously chasing after the attackers, now it's the attackers who have to chase the defenders, because the defenders are moving around the application memory, the memory structure, turning it into a moving target. Now, how does Morphisec implement moving target defense? It takes only 2 steps. And what we see here is a diagram of an endpoint. And to reiterate, the endpoint includes a disk and the memory. Now, we see here on the slide a bunch of very commonly used Windows-based applications. We see Microsoft Office applications, we see internet browsers, and so forth. But I'd like to emphasize that what I'm about to describe is applicable for any Windows-based application whatsoever, even a specific homegrown application, proprietary application, which was homegrown or developed in a certain specific company, which only it uses that specific application. Now, if I think from the eyes of an attacker, and let's put now Morphisec aside and think through the eyes of an attacker, if I want to exploit a certain vulnerability in a commonly used Windows-based application, all I need to know is, first of all, if and which application has vulnerability. Let's say that Google Chrome has a certain vulnerability. One of the DLL files is vulnerable. And by the way, this is not far-fetched. About a couple of months ago, Google Chrome did have or did suffer from a very severe vulnerability that later Google needed to patch. But let's say that Google Chrome, for the sake of the example, has a vulnerable DLL file. And if I'm familiar with the rules of Windows, I will know which naming convention Windows or the Windows loader will provide to that vulnerable DLL. Let's say that it calls it b.dll, and that it always loads b.dll to this part of the application memory, of the memory structure. Now, it's easy for me as an attacker to orchestrate an attack which will exploit this vulnerability, because I know which DLL file to call for, which is a vulnerable DLL, which I know is called b.dll by Windows Loader, and I know that Windows Loader always places it right here at this part of the application memory. So I can rather easily orchestrate my attack and exploit the vulnerability to penetrate the network through the memory. And this is exactly how memory-based attacks take place. What does Morphisec do to stop this, to prevent this? Morphisec takes 2 steps only. The first step is the most important step, and we call it morphing. What does morphing mean? We take this memory structure, which is what the attack has been orchestrated to look for, and where all the sensitive data is stored right now, and we take various steps that we call morphing, which at the end of the day or end of the process, turn this application memory into something which is completely uncomprehendable or virtually invisible to the attack. So this application memory, where all the sensitive data is, and which the attack is after, and which the attack was programmed to look for and to identify, now turns into something which is completely unrecognizable by the attack. If it's unrecognizable by the attack will not even approach this area of the memory to search for the vulnerability it was programmed to search for, because it doesn't know how to comprehend this morphed application memory. It's a complete disguise. By this step on its own, we achieve the impact of prevention. Because the way it works from a flow base is, every time we have a client which is stored on your endpoint, the endpoint can be a laptop or a PC, so forth. Every time a Windows-based application is triggered either by double-clicking on the desktop icon or double-clicking on an email attachment, the application starts to load, and Morphisec morphs the real application memory. This, turning it into this. If there's no attack on the endpoint, if the endpoint is clean, no issue. Any legitimate Windows-based application will seamlessly load through the morphed application memory, and the user will not feel a thing. The loading process will be completely transparent, even though the application is now loading through the morphed application memory and not the original application memory. So basically, everyone is happy. I have Morphisec installed on my endpoint right now on my laptop. I'm running this PowerPoint presentation. It loaded seamlessly, it's working perfectly, and everything is fine. But if there is an attack on the endpoint, the attack cannot do anything. It cannot approach the data it was programmed to look for, because I morphed the application memory, and now the data is safe. So this is how prevention is achieved. But we yet take a second step. And the reason we do this is that our solution includes what we call a security center or a management console. The management console is a mere console. It does not push anything, but it receives information, forensics information of the attack in case the attack is on your endpoint, because we want to provide the visibility through our management center, through our security center, of what happened. What did we manage to prevent? What type of an attack tried to attack your endpoint that Morphisec has managed to prevent? The way we feed our management console with that type of forensics information is through luring or tempting the attack to approach a trap that we create. Because through the morphed application memory, we cannot retrieve any information, because the attack will not approach the morphed application memory. So we create a trap, we create a decoy, which you can see here in gray. This decoy, which chronologically is created a split of a second after the morphing process, from its outskirts looks identical to the original memory structure, which what the attack is after. This is what the attack has been programmed to identify. So if now, all of a sudden, the attack sees something it does recognize, it will be tempted to approach this part of the memory. And this is what happens. An attack, seeing the skeleton application memory, will approach the skeleton application memory, believing it's the real application memory, and searching or hoping to find the vulnerability it was programmed to exploit. But it will not find any vulnerability because only a skeleton. There are no DLL files inside. This is basically hollow. But once the attack reaches this area, this is enough for Morphisec to take a snapshot of this part of the memory and send this forensics data, this raw data, to the security center, feeding it with the necessary information it needs to then conduct some analytical layers and provide very chewed and detailed information of what happened, which attack tried to exploit vulnerability, and Morphisec has managed to prevent. So these are the two steps that Morphisec takes. And with these two steps, three very important differentiators are achieved. First and foremost, prevention, like I've elaborated before. But mind you, this is not only prevention. This is prevention without doing any scanning, without doing any hunting, without doing any targeting, and without dependency, without whatsoever on any prior knowledge. And this is why, through Morphisec's implementation of moving target defense, Morphisec is 100% efficient in stopping or preventing that unknown factor, including zero-day attacks. Because Morphisec does not need to know anything about the attack. It is agnostic to the attack. It does what it does regardless. And this is a very, very important, even dramatic differentiator. The second one is the deterministic effect. And with your permission, I will jump back to a slide I presented before. And I'm referring to this slide. And I've mentioned and elaborated that detection-based solutions use all sorts of techniques or technologies which are intelligent on their own, like machine learning, sandboxing, etc. But they are all based on assumptions. They're all based on a heuristic algorithm. So any abnormality which they assume is an attack, they will raise a flag. The problem is that many times this flag is raised in vain, and we call this a false positive alarm. And you speak with any security administrator or security director, and he will tell you how many false alarms he receives per day. And the problem with these dozens and dozens of false alarms is not only that they're time consuming and annoying, but they're also resource draining. Now, going back to the way Morphisec works, with Morphisec solution, anything that reaches this part, this skeleton application memory, by definition is bad. What is bad is not legitimate. Legitimate is a program which follows the rules of Windows. So any program that would follow the rules of Windows would seamlessly load through the morphed application memory, like I have elaborated before. So by definition, anything that lands on this trap of skeleton application memory, by definition, is bad. I will not say that Morphisec has zero false positives. No one has zero false positives, and Morphisec can have an occasional bug, etc. But the number of false positives that Morphisec solution produces is very, very marginal in comparison with other detection-based solutions from the reasons that I've outlined. The third dramatic differentiator is what we refer to as resilience. And resilience links back to moving target defense and why we call our solution or basing our solution in moving target defense. With resilience, we mean that each time we conduct the morphing, meaning every time you double click or a user double clicks on a Windows-based application and we morph the application memory, we randomize the steps we take in order to do the morphing. In that way, we leave no chance to any adversary, to any attacker, to overcome what we do and to bypass us. Morphisec proudly says it's been deployed in more than 5.5 million endpoints globally today, and it was never, or its solution has never been bypassed ever since. So these are the basics and the main differentiators between Morphisec and its move and target defense solution to all the other detection-based solutions out there. I hope I managed to communicate properly these differentiators, and I'll be happy to take any questions through emails. Thank you so much, and bye-bye.